Alright, today we're going to compare resultants and resolution of vectors. Uh, the first thing you must know is that a vector is a quantity that has both magnitude. It has both magnitude and direction. Magnitude talks about its size, alright? It can be measured, it can be quantified, right? And then it also has direction. Example, the opposite of vectors are scalar quantities. For instance, let me use something we use every day. Let's say rice, right? Rice can be measured, right? So since rice can be measured, it means it's a quantity. And in small scale, rice can be measured in cups. I mean, in this part of the world that I live, we measure rice in cups. And then in large scale, it can be measured in bags. So, for instance, we can have like 5 bags of rice. That 5 bags shows the magnitude of the rice, all right? That's the magnitude of the size of the rice we've measured. However, we cannot give a specific direction. We cannot say, it doesn't make sense to say 5 bags of rice in the north direction. It doesn't make sense. So scalar quantities just tell us the magnitude. However, vector quantities tell us magnitude and direction. For instance, force. Force is a vector quantity. So for this video, I'm going to be using force as my vector, all right, to explain or rather to differentiate what we mean by resultant and resolution. It's very important to know this in physics because most times you're going to be finding resultant of a vector, or we will resolve the vector back to the components. So remember that force is measured in newtons. All right, so let's get down to business. What do you mean by resultant vector? Okay, now let's consider a simple case. Let's say we have 3 points, A, B, and C. All right, and let's say that we are going to be starting from the point A. So let me say that, remember, we're going to be using force for the example in this video. Now let's say that we have a box at A. We have a box. Now we want to get this box to that point C. We want to move it from A to C. Of course, you know that force is an art that changes the position of a body, so nobody would move except you apply force. So from A, I will apply a force, upwards to B. Alright, so if you're representing vectors, you must put an arrow to indicate the direction, since vectors specify both direction. And then how long the vector is the magnitude. So I'll apply a force in this direction, and then I'll apply another force from B to C in this direction. Alright, so I've successfully moved this box from point A to point C. Alright, so we can just put values to that. Now, if you remember from your Cartesian plane, something like this, you remember that this positive direction, this upward direction is called the positive y-axis, while the opposite side is the negative y-axis. This is the positive x rather, while this is the negative x, right? So when we are moving this body from A to B, see that we're along the positive y-axis. However, in this video, or rather for this example, I don't care about whether it's positive or negative. I just care whether it's along the y-axis or along the x-axis. So you see that this first force we apply from A to B is along the y-axis, and since we are considering force, let's call it Fy. So we apply this force in the y-axis, that's the vertical direction, which is the y-axis, right? Then from B to C, you see that we're applying the force in the horizontal direction, that's along the x-axis. Now, what is resultant? So we have two forces, Fy and Fx. What's the resultant of these forces? The resultant is one single force that can do the same thing these two forces are doing. So I just want to, my main objective is to move this box from A to C. I can also decide to apply this force in this direction exactly. From A, I'll still get to C. Alright, so instead of taking the first route of the Fy and Fx, I'll just apply one single force, which we're going to denote as just F, to get back to get the same effects, right? So that's what resultant means. Resultant is one single force that can do the same work other forces are doing in a system. Now remember, I said that I'm going to use force as my vector, So it's not only force, every vector quantity, acceleration, velocity, in anything that has magnitude and direction, the resultant is one single force, which is F in this case, that will achieve the same thing other forces are doing, which is Fy and Fx. So, of course, the x and y plane are always at right angles to each other, right? So you see that to get the resultant force, when you have forces acting perpendicular to each other, you can always use Pythagoras theorem, because this forms kind of a right angle triangle. I'm going to say that the resultant F squared will be equal to Fy squared plus Fx squared. So you need to know this formula. Anytime you have forces acting perpendicular to each other, the resultant will be given by Pythagoras theorem. You can also use the trig ratios, but mostly why use trig ratio when you can just use Pythagoras theorem, since the resultant is always the hypotenuse. Now, that's it for resultants. What of resolution of vectors? What do you mean by resolution? Resolution is just the opposite of resultant. So in resolution, I'm going to use this same example, this same setup. In resolution, you'll be given the resultant instead. Alright? We still have the same points A, B, and C. So, resultant is the force that takes it from A to C exactly. So if we're asked to resolve these forces, what we simply mean is that you should bring back the original two forces that will move this box from A to B and from B to C. Seeing that if I move this box from A to C, this force is doing two things at the same time. It's moving this box upwards, alright? It's moving upward, which we call the vertical component, that's Fy, and it's also moving this box horizontally, which we call the horizontal component, Fx. So this is Fy, while this is Fx, right? And then they are inclined at an angle here and also at an angle here. So let's call this angle theta. Now this is F, don't forget. So the force that moves from A to C is the resultant, alright? While the force that moves it from A to B is the vertical component of F, while the force that moves from B to C is the horizontal component of F. So if I ask you to resolve this F, this is my original vector F, I mean you should bring out the vertical component and the horizontal component. So how do we do that? We use our trig ratios. Since F is the hypotenuse, and then it will be inclined at an angle theta to the horizontal, that's with Fx. So using our trig ratios now, remember the SOHCAHTOA. Since this the resultant F is the hypotenuse, Fy, you recall that Fy is the opposite side. Please, always important to identify the sides. Fs is the adjacent side, while F is the hypotenuse. So if you are considering Fy is opposite and F is hypotenuse, so we're going to use the sign. So we're going to say that sine theta will be equal to opposite over hypotenuse, which is equal to, opposite is Fy, hypotenuse is just F. Now if we cross multiply, you see we are going to have Fy to be equal to F sine theta. So this the formula we always use to find the vertical component of a vector, in this case force. Why Fs is adjacent and hypotenuse, so we are going to use cosine. So we're going to say cosine of theta will be adjacent over the hypotenuse. The adjacent is Fx, while the hypotenuse is F. So when we cross multiply, I'm going to write somewhere here. See that we're going to have Fx is equal to F cosine of theta. So this is the formula we need to calculate the horizontal component of any vector. So you see we need three formulas. If we are given the Fy and the Fx, we use Pythagoras theorem to get the resultant. But if we are given the resultant to find Fy, we do F sine theta, to find Fx, F cos theta. So this is the formula you need.